Welcome, ladies and gentlemen. Today we will talk about data management. I'm Gioele Masini. I work with Angular since 2014, and today I work in San Marino at Dynaset. We develop an HR application which some of you probably use today to say that you are here instead of in your office. And today we will see how we optimized our data handling. We will see our code history. So the first question is how we have to what architecture we have to use to handle our API data. The first option, obviously, is direct request. It is the simpler, and it has really low code, but it's still useful today because if you need real-time data or data consistency or something like that, obviously you have to ask it to your server. Or sometimes you have some resources constraints in your devices, so you can't have local data. But that's not our case. That's why we decided to use a local cache in our front end. It is really useful when your application can have latency sensitivity, so local data is really faster to be available. And is also very useful when you have a frequent data access, so you could have redundancy in API requests. And as you saw earlier, you can also do the same thing for offline access. On your right, you can see our file organization. We added two services, one storage service and one sandbox service. The storage simply holds our data, while sandbox will be our glue to manage the interoperability between our storage and API. From our components, from its perspective, it is simply the only way to access our data, so to read or to edit our data. Our sandbox is an abstract layer to divide our UI logic from our business logic and our APIs. Why local cache is useful? Because obviously it reduces network traffic and also reduces server load. This way we use an optimized resources, and our applications, both in front end and in back end, improve its performances. This way our users also have a better user experience because our front end is really faster rendering its user interface. Obviously, you probably know these third-party libraries, Akita, NgRx, NgRx, but we decided to don't have external dependencies. Why? Because if we do it ourselves, we could customize our code to fit our application at its best. We have obviously less dependencies, and making this code, we and me and my team gained some experience and knowledge. What we need to realize, obviously we have a storage to hold our data. We have to handle data changes events, and in these cases we decided to use data flows to be reactive when we have some data change. And we need some mechanism to load data from our backend and reuse data when is requested. Our first implementation of our storage was based on RxJS. In this case, our data is registered on our behavior subjects, and we have simple setters, and our getters retrieve the behavior subjects in a read-only object, in a read-only way. We will also use a wrapper object because this way we are able to remember to know what is the state data, if it's loaded or not. And also, if necessary, we can still handle error messages of our backend. This is the first implementation of our storage. As you can see, it's really simple. This is obviously a minimal example, so there are also some more difficult cases, but it's the base. We have an instance of a behavior subject. We use the storage, which is our wrapper object, and it contains our server data. We initialized our data using a simple utility to reduce our code boilerplate, and we initialized it with a simple empty array. Then you can see our getter and our setters. One important thing is to remember that our getter don't have to be a function here, because if you create a function, you simply repeat and repeat the use of the function as observable. This way you call it one time and it's enough. Here you can see a simple implementation of our storage wrapper, the enum we use for our load status, and the implementation of one of our utility functions. And this is the implementation of our feature sandbox. Normally, we create a pair of component and sandbox for every route we need to create. Sometimes a single sandbox can be shared between multiple components of the same feature, when possible. The important thing we do here is to hide our load status from the component, so this way its code is really simpler. And it is able to read our data only when it's available. We decided this because we have a global loader, so our component interface is hidden by our global loader, so it's not really important what it shows, if it shows something empty, until data is loaded. And this is a simple implementation of it. Here we have the most important lines here, and one thing which is really important is to remember that we have to use a sync pipe. Another thing you can see is that we are using inject function, which is one of the latest way you can inject services in Angular. What we can say about async pipe, that it's an impure pipe. So it is a third, an external library we use in Angular. So it's not really integrated with our framework. Angular made it to help us to develop using observables, so using data flow, but it's not really integrated in our framework. So because it's impure, we don't have the best performances of Angular. That's why, that's one of the weak points of RxJS when it's used in an interface. The others are that it could have a code complexity, or it's also memory leaks. It can have some memory leaks if you don't pay attention to it. That's why with the release of Angular 16, we decided to realize the same code, but using Signal, also if they were still in beta. the theory is the same and the code is really similar. That's a good thing. So thank you, Angular, for these interfaces. Data is stored in writable signals. Our getters simply retrieve the writable signal, but in a read-only way. And we have no more external libraries, at least to develop our user interface. Let's see our code. You can see that it's really the same. To create an instance of a signal, we have the function signal, and we have as read-only and a setter. Nothing else. It's really simple. The usage is just a little bit different because we have to use computed in this case. The code of Angular signals is different from RxJS. We don't have operators. And in this case, we couldn't use the filter. So we always have to return some value. In this case, I already explained why we decided to return an array when our data is not loaded or not available. And this is the component. It's the same as before, almost the same. It doesn't have this async pipe we didn't like. We have also some additional advantages using signals because these advantages are free to use. We don't have to do anything because they are integrated inside signals implementations, because our code will be laterally evaluated. So our user interface is not refreshed when is not needed. It also, for the same purpose, has memoization. So if the result is the same, we have to do nothing more. And signals are part of Angular code, so they are really integrated inside our framework. Angular will do everything could do to have the better performances, and they are written to realize user interfaces. That's why they are also ready to be zoneless. And in this way, we are already thinking to the future, because today it's not really available an Angular zoneless. But today, tomorrow, we will be ready to use it without doing any change to our code. So this is a real good thing. What we have to do now, we need obviously some code. We still need some code. And we have to create some function to create interoperability between our storage and API. And we need to find some ways to determine when and why we have to invalidate our data. Let's talk about interoperability. Our CacheOperator is the function we developed to realize the communication between sandbox, storage, and APIs. It's an automatic function which loads data when not available and save it on our storage. It also permits to get it so that the sandbox can use it to provide our data to our components. This is the code for our first implementation. Let's see the signature. It has two input functions, an API function which will make the API call, but we don't know how. We have a setter function that will update our storage data, and still here it doesn't know where. It's a generic function. And it will return an operator function, because this way we can use this function as an RxJS operator. So it will be easy to be used. We have a store inside, because we have to remember to do some conditions. when we have to call the API, when data are already loaded, if there is some error or something like that. Here we have the API handler, which do a simple thing. It calls our API function, and if the result is a success, we'll store our data in our storage using the setter function. And when there is an error, it will store our HTTP error and its status. Then we have finally the implementation of our data flow that will be returned by our application. We have used simple RxJS operators. We filtered some states because if loading we have to do nothing because we are already called the API, and this is useful if you subscribe to this data flow multiple times. And then we evaluate if we should or not call the API, because perhaps we already have our data. Our data is already available. Then we filter another time to be able to give data only when loaded, and we return its value. Its usage, as we said, it's really simple when we write our sandbox. Our CacheOperator is really reusable, so you simply have to use it on a data flow from your storage. This is an example of its code. Normally we use share replay to be sure that it will use it only one time. It's important to remember here that the configuration of share replay, so that after the component is destroyed, this code will never run. Otherwise, you could see its API called even if you are in another route, because you are still subscribed. Not you, share replay is still subscribed to our CacheOperator. We then improved our function when signals were available. So we had simply to add one data flow as input this time, because signal code is different from RxJS. So we received in input our data flow. We have the same state as before, and also API handler is really the same as before. So that's why, because observables are still useful today, we have to use them in some cases when handling APIs logic or business logic. It's still a good thing. But when we want to provide data to our UI, it's better to provide a signal data flow like this computed. So we retrieve our stored data and we evaluate like before in our sandbox if our data is available or not. In this case, we decided to return a null because it's a more generic value available inside our language, but you could decide to return something else, perhaps some default value if necessary. And this is its implementation. It's even simpler because simply you use the function, nothing else. You provide the 3 input elements and it's all. Now we can see our designs of data invalidation. Also here we will see our history, the history of our application. So it's a walkthrough. Manual update, simply because sometimes it's better to manually reload with a button than refreshing the page, because it's a big application, a single page application. It needs some seconds to load sometimes. It depends on the feature you are using, but it's a possibility for the user. So this was the first implementation. How it works? Simply, our sandbox say and use a function we decided to call clear of our storages, and this function simply clear all data in our storage. This way, our data became unavailable. So our cache operator says, wow, data changed and is unavailable. So someone wants it because it's subscribed to us. So I will call another time our API and I request updated data. And I save it on our storage. Then we improved our way to invalidate our data. We thought, we have some events which are useful for this, and we decided to use Angular router events. That's why we decided to create what could be called a feature-based storage and not a centralized storage, because our application is really big. It has many different modules and really many different functions, and it's really hard that they share data. In this way, when the user changes page, we evaluate if he is in the same subpath as before, so we keep the data available. So if the user returns to the main page, you still have the value available. But if it changes its page, so its route, data is cleared. This is our choice. So you could have another choices in your application. We created this clear service. We simply observe our navigation, our user navigation, and tell, well, in reality, it tells to sandbox to clear storage, but it's the same. And this was the first event-based invalidation. We had another more advanced implementation, but also heavier, because it involves our backend. We decided to use server-side events. This way, when needed, we can ask to our server, or it's better to say, our server says, using server-side events or WebSockets, says that, well, this data has changed, so you should update it if you need. If you are watching a component with this data. We used SignalR, but it's also possible to be implemented manually. We used SignalR also because in our backend we use C#. So Microsoft, thank you for this library. This is what decided to implement. We had some benefits and impacts to our application. We have less redundant API requests. Before this code, every page we open was an API call. While now you can navigate inside the same feature multiple times or for more time, and you don't have to do the same API request multiple times. We have a better code architecture. As I told you, we have a sandbox, and the sandbox is a good abstract layer to divide our UI logic and our business and API logic. This way we have more isolated code, so more maintainable, and if tomorrow we will have to recreate a different UI for the same feature, we still can use the same sandboxes, perhaps the same sandboxes, surely the same business logic and the same APIs. We created a feature application state handling, so it fits perfectly our application and we don't have more code than what we need. And we have a better user experience and a cleaner code. What we learned? We learned that it's really useful to follow Angular news and to be updated, because in this way we already knew that what signals were, while they were only designed, they were not implemented or at least not released. So we were already ready to use signals before Angular 16. So we could think in the future. We created something really KISS, so simple to use, and we can say that our custom solutions are pretty good and well designed. Our future directions are to try to recreate the same filter as we had in the first implementation with observables, and now we don't have to in our signal implementation. It could be useful sometimes to reduce our code and so to be easier for our developers to create new routes and new pages. We wanted to realize a completely stateless cache operator without complicating too much our code, because probably the same state we store in our cache operator is really similar at the state we save on our storages. But we need something more to get its storage data. Actually, we don't have access to the storage data. We only are able to save data. And we could evaluate a more advanced caching system. So something like a caching validation, if it will be valid. That's all. How many times we still have? Thank you. How many times still we have? 12. Okay. We can see our utility functions. Well, it's really interesting because, not this one. Sorry, this one. Oh yeah, no. You are seeing the right code. Sì. I'm coming, sorry. It's my first international talk today, so we realized some utility functions which are pretty useful, because when you develop your storage, not always you have simply an empty array, an array of data, because we normally use it when we visit our main page, where the user can see everything he can watch in a little way. So we have also some detailed page. This is why we have to save both of them normally. We have different APIs, different results, and different data in these APIs. That's why we created principally two different utility functions. One which saves main data in an array, and another one which saves single data, detailed data in a map, where you can access data using their ID, and you can check if they are already available or not. That's why we realized this code. Okay. Set single in a map. It is able to do more things, three things: to add, edit, or remove our data. So it's not that hard, but I'm here to show you how it's implemented in a good way. We check, obviously, if the load status is an error. And in this case, we decided to don't store it, but because there is one thing I cannot show you now in this little code, but because we provide a notification to the user when there is an error. So we already handled the error. We don't have to store it to show something in our component. And we use our update function here, which is the signal function. Obviously, we are watching our signal implementation of these utilities, but we had also implemented the same code using observables, but we will stay in this newer version. And then we evaluate if our data must be deleted. We use it undefined to realize that we have no value, no backend result, because a backend can send you using JSON, can send you a null value, but not an undefined value. This way we know that undefined is used only in the front end. And this means that we have to delete our data from our map, or we have to add or update our value, and we simply overwrite it. But we also have to update our list data. If the user decides to enter in the detail and delete this object, we have to return to the list we saw before, and we have to show it's updated. We could do another request, but we decided to don't do it, to update the list manually, but automatically, which is a good thing, and reduce, the purpose was to reduce server load. This way, we simply, the code is a bit more complex than you probably need, because we had some legacy code we had to maintain. But what we do is to retrieve the ID value and to evaluate if the code, if our list is loaded, so we can change it. We search our ID and we update our list consequently. So also here we remove, add, or update the list. When we update, we check to be in the same order as the object we had before, and simply we update the list with this new created array. This way, we can create, this is a real example of a storage, of a complex storage. This way we can create setters with just one function, which returns the created function. It is a factory, simply. It is a pattern we decided to use, providing simply our two signals we use to store data. He is able to create our setter function. So it is almost one line, or if you write really a lot of long names for your resources. And well, this is what I can show you. We also created some utility function for getters, because when you want to retrieve a data, a resource from a map, obviously you need some lines to search data inside the map, and something like this. But this way we really add a simple to write store. And when we needed to do some custom code, we could still do it without any problem, because in any moment we can decide to use our utility functions or to create our different code for particular occasions. I think we have done it, so thank you.
Thank you very much. We have a lot of questions for you and a few times, so I will ask you just a few. In the store and sandbox provided in root, is the store and sandbox provided in root?
We decided to don't provide in root at least sandboxes, because we create a sandbox for every component. That is why we decided that it's a simple way to not be able to use our sandboxes wherever. So in this way, you must use the same the single sandboxes when you need to use them. While a storage could be provided in root, because our stored data could be used in many features and so could be shared between many sandboxes.
Then someone asked, NgRx provide new signal store. What do you think about that? Are there some cons using that?
Well, I read its documentation, but we decided to don't use signals for one simple motivation. We doesn't need a complex storage system. So RxJS comes and it's very powerful. It provides many features, but as you saw in our presentation, we have KISS code, simple code. So we didn't want to import and to work with a library complex sometimes to use, or at least complex to be studied, because you have to really well understand its functionalities, and to work with them at the best. That's why we decided to create it ourselves as a first thing. We watched, we need something else, we need more, and we decided that we didn't need more. But you can do the same if you want. You can try to create, when you start your application, to create your storage, your custom storage, in a simple way. And if you see that some more functionality, like more debugging facilities that you can use with RxJS, with NgRx, you can still change in a fast way, because also we, as it, we provide signals, so it's not so hard to change library.
Last question. Is there a toy project StackBlitz to explore the really cool looking new operators and generic update function?
The code I put in these slides is perfectly functioning. I created a little project. I will be honest, I didn't put it publicly. It is only on my PC. But if you try to create a new project, a new Angular project, and put in the code you saw here, you can really see that it's working. So I don't think it's so necessary to create a public repository. But if you need it, you can connect to me and ask it. I will send it to you without any problem.
Thank you very much, Gioele, again.
Thank you too.